Good morning, good afternoon, or good evening, depending upon where you live around the world. This is going to be a really quick one. Just building on the idea of this strut and the attachment points. I was noting, logically at least, that if we've got the orientation of the rod in this direction, any rotational force that would occur around this axis would be reduced or mitigated by the fact that we've got an opposing line of rotation here. So the strut is more inherently stable when there's two opposing lines of, or the potential for rotation. Were we to use this arrangement, the fact that these two, the major rods that are securing the strut and hub together, would be in line if we were to replicate this on the other end, means that there is the rotational potential, at least in the strut, which would be negated by this screw. I can't see that being a problem. But in here, because we've got two lines of rotation or potential rotation for the strut, they're being counted, and the screw would therefore be doing a secondary and minor job to that prevention of the rotation. It can't be left out. We still need a fixing of some description at both top and bottom, because even though that if there was load, let's say wind or snow or both, this is the rod that would want to be doing the majority of the work in this position. It wants to be in the middle or lower half, but the screw would be used for the prevention for the hub trying to separate from the strut in a wind upload situation. And remembering that a wind coming across the surface and being deflected up and over can create an airfoil type situation. On the leeward side there can be negative pressure, so there can be separation at this point between the hub and strut. I think this particular screw, which is a reasonably heavy gauge screw and it's 200 millimeters long, would, I think, do the job to prevent that from occurring. We certainly could have two heavy rods placed, but I like the idea of this because we can insert the screw from the outside after it's been assembled using the main rod. And yes, you could also insert a heavy rod in the same manner by screwing it in via probably a drill, an attachment, into the strut as well. So that's certainly up for consideration. I don't know whether that would be necessary. I think this rod would be more than sufficient for the size domes we're using, but again, I can't quantify that. That would be the purview of an engineer, but gut feeling is that a 12mm rod and a heavy screw in here would make this a very, very strong attachment. If necessary, that could well be a rod placed into position just as in the screw, and that would be an incredible attachment. As I say, as the wind, as the structural loads go up and the size of the dome gets bigger, that may well be an issue that we need to replace a screw with a metal rod. Again, that would be back to the criteria or the design requirements that would be told to us by an engineer. Rightio, told you that was going to be a short one of my shorter videos. I'll leave you with that and I'll see you in the next one. Rightio, bye.